Hey, ever wondered how engineers design sleek airplanes, optimize car aerodynamics, or even predict weather patterns? It is all thanks to something called computational fluid dynamics, or CFD. Stick around for 3 minutes and I will break it down for you in a way that is easy to get, no engineering degree required. CFD is like a virtual wind tunnel. It uses math, computers, and a bit of magic, okay, not really magic, just super smart algorithms, to simulate how fluids like air or water move. Think of it as a video game for fluids, but instead of battling aliens, we are solving how air flows over a plane's wing or how water swirls in a pipe. Here is how it works. Fluids follow rules, math rules, like the Navier-Stokes equations. These equations describe how fluids move, but they are super complex. CFD takes these equations, breaks the fluid area into a grid or mesh, like a digital puzzle, and solves them step by step on a computer. This grid is key. Imagine slicing a river or the air around a car into tiny pieces. Each piece gets calculated for things like speed, pressure, or temperature. The result? Awesome visuals like these. Check out the airflow over this car. CFD is everywhere. It is used in aerospace, designing planes that slice through the air with less drag. Automotive, making cars faster and more fuel efficient. Energy, optimizing wind turbines, or even modeling combustion in engines. Even biomedicine, simulating blood flow in arteries. Cool, right? So how do engineers do this? They use software like Ansys Fluent, StarCCM+, or the free open-source OpenFOAM. The process has 3 steps. First, pre-processing. Build a 3-dimensional model and create that grid I mentioned. Second, simulation. Let the computer crunch the numbers, sometimes for hours or days. Third, post-processing. Turn the data into colorful visuals to analyze, like this. But it is not all smooth sailing. CFD can be tricky. It takes tons of computing power, especially for turbulent flows, like stormy air or choppy water. Plus, if your grid is not good, your results might be off. And you always need to double-check your simulations with real-world tests. Why does CFD matter? It saves time, money, and lets engineers test crazy ideas without building expensive prototypes. Imagine designing a rocket or a heart stent without ever leaving your computer. That is the power of CFD. Want to dive deeper into CFD or see it in action? Drop a comment, hit that like button, and subscribe for more science and engineering goodness. Oh, and if you are curious about free CFD tools like OpenFOAM, let me know, and I will cover it next. Catch you in the next short.